Hi all, my name is Matthew Abraham, Assistant Professor at Rajagiri School of Engineering Technology. In this section, we mainly deals with the three important topics. First one is backup topologies. Second one, backup in network attached storage device environment. Last one, backup target. First topic is called as backup topologies. Three basic topologies are used in a backup environment: direct attached backup, LAN-based backup, and SAN-based backup. A mixed topology is also used by combining LAN-based and SAN-based topologies. In the case of direct attached backup, a backup device is attached directly to the client. Only the metadata will be sent to the backup server through the LAN, so that this configuration frees the LAN from the backup traffic. The figure shows that when the environment grows, there will be a need for central management of all backup devices and to share the backup devices to optimize the cost. The appropriate solution is to share the backup devices among multiple servers. In this example, the client also acts as a storage node that writes data onto the backup device. In case of LAN-based backup, all servers are connected to the LAN and all storage devices are directly attached to the storage node, so that the data to be backed up is transferred from backup client, that is source, to the backup device, that is destination over the LAN. So if the server and the source are directly using the LAN, which may affect the overall network performance. SAN-based backup is also known as the LAN-free backup. So the figure illustrates the SAN-based backup. In the case of SAN-based backup topology, it is the most appropriate solution when a backup device needs to be shared among multiple clients. So in this case, the backup device and the clients are attached to the storage area network. In this example, the clients read the data from the mail server in the SAN and write to the SAN attached backup devices. The backup data traffic is restricted to the SAN and backup metadata is transported over the LAN. Mixed topology uses the combination of LAN-based and SAN-based topologies. This topology might be implemented for several reasons: cost, the location of the server, reduction in administrative overhead, and performance considerations. Next topic is backup in network attached storage environment. Network attached storage delivers a more efficient and effective way to protect data by providing a network-based centralized backup model. The NAS controls the backup process of all the clients and servers, providing centralized disk and tape storage. This centralized network approach reduces the amount of equipment required for backup operation, and it will lower the management cost of backup administration. Network attached storage is the best choice for backup operations in the following three scenarios: client backup, server backup, and remote replication. In the case of NAS environment, the backup can be implemented mainly four different ways: server-based backup, serverless backup, or using network data management protocol, mainly two ways: two-way backup or three-way backup. In the case of application server backup, the NAS head will retrieve the data from a storage array over the network. Then this data will be transferred through a backup client. The backup client will transfer the amount of data back to the storage node. The storage node will write this data back to the backup device. So there is a large amount of traffic will be a rise in the network. This will affect the overall network and the system performance. In the case of serverless backup, the network share is mounted directly onto the storage node. So this will avoid the overloading the network during the backup process. At the same time, it will eliminate the need to use resources on the production server. The figure illustrates the serverless backup in the NAS environment. In this scenario, the storage node, which is also a backup client, it will read the data from the NAS head and write it to the backup device without involving the application server. Compared to the previous solution, this will eliminate the overloading of the network. NDMP, Network Data Management Protocol. It is an industry-based TCP/IP based protocol used for moving data across the network for backup and recovery. It can communicate with several interfaces for data transfer. At the same time, it will independ upon the operating system or the platform. It is more flexible. It is no longer necessary to transport data through the backup server, which reduces the load on the backup server and improves backup speed. In the case of Network Data Management Protocol, backup data is sent directly from the NAS head to the backup device, and the metadata is sent to the backup server. The figure illustrates the backup in the NAS environment using Network Data Management Protocol in two ways. In this model, network traffic is minimized by isolating data movement from the NAS head to the locally attached tape library. In the case of Network Data Management Protocol three-way backup, the data is not transferred over the public network. We construct a special type of private backup network that is established between all NAS head and the backup NAS head, so that the backup NAS is tried to prevent any data transfer on the public network, so that it will avoid any congestion or affect in production operation. We transfer only metadata and NDMP control data through the public network. This method is very useful when we have limited backup device in the environment. Wide range of technology solutions are currently available for backup. Tapes and disks are the most commonly used backup media. The tape technology has matured to scale to enterprise demand, whereas backup to disk is emerging as a viable solution with the availability of low-cost disk. So in the case of virtual tape libraries, use disk as backup medium, emulating tapes, providing enhanced backup and recovery capabilities. Tapes are low-cost technology which is extensively used in backup operation. Tape drives are used to read or write data from the tape cartridge. Tape drives are referred to as a sequential or linear access devices because the data is written and read sequentially. Several types of tape cartridges are available. They are vary in size, capacity, shape, number of reels, density, tape length, tape thickness, tape tracks, and speed. A linear recording method was used in all the tape drive technology. But in the case of modern tape drives, it will utilize linear serpentine method. Tape library provides housing and power for a number of tape drives and tape cartridges, along with a robotic arm or picker mechanism. The backup software has an intelligence to manage the robotic arm and entire backup process. So in the case of modern drives or tape drives, It consists of an indexing mechanism that enables a tape to be fast forwarded to a location near the required data. The tape drive then fine-tunes the tape position to get the data. Next topic, the major limitations of a tape. Tapes are mainly used for long-term storage mechanism. At the same time, it provides their low cost. Tape must be stored in locations with a controlled environment to ensure the preservation of the media and prevent corruption. Data access in a tape is sequential, which can slow the backup and recovery operations. Disk now replace the tape are the primary device for storing backup data because of their high performance. Backup to disk system offer ease of implementation, reduced cost, and improved quality of service. At the same time, disk will provide high data transfer rate. It can be used for faster recovery operation when compared to tapes. In the case of backup operation, the disk will provide the random access of data. At the same time, it provides read protection capability. In most backup environment, backup to disk is used as a staging area where the data is copied before temporarily transferring or staging it to tapes later. This enhances backup performance. Some backup products allow the backup images to remain on the disk for a period of time even after they have been staged. Virtual tape library provides a number of features that are not available with the physical tape libraries. Some virtual tape libraries offer multiple emulation engines. Compared to physical tape, virtual tape offers better single stream performance, better reliability, and random disk access characteristics. Backup and restore operations are sequential by nature, but they benefit from the disk random access characteristics because they are always online and ready to be used. This will improve the backup and recovery times. Virtual tape does not require the usual maintenance tasks associated with a physical tape drive, such as periodic cleaning and drive calibration. Compared to backup to disk drives, virtual tape offer easy installation and administration and inherent offset capabilities. At the same time, virtual tape do not require any additional modules or changes on the backup software. Virtual tape library has the same components as that of physical tape library, except that majority of the components are present as virtual resources. In the case of backup software, there is no difference between a physical tape library and a virtual tape library. Virtual tape library use disk as the backup media. This figure shows that the comparison between physical tape, disk, and virtual tape. So physical tape and virtual tape are used only for backup operation, but in the case of disk, we can use it for multiple operation. When we deal with the performance, the disk and virtual tape offer high performance, but in the case of tape, they perform only very low. In the case of reliability, the tape will not provide any kind of protection mechanism, but disk and virtual tape provide read protection mechanism. In this section, we discuss about backup topologies, backup operation in NAS environment, and last one, what are the different types of backup devices.